In physics, scalar and vector quantities are two different types of measurements used to describe the physical properties of objects and phenomena. The main difference between them lies in their characteristics and mathematical representation. Scalar quantities. Scalar quantities are physical quantities that have only magnitude, size, but no direction. They can be described by a single numerical value and a unit of measurement. Scalar quantities are represented by real numbers and do not require a specific coordinate system to be defined. Examples of scalar quantities include mass, temperature, speed, distance, time, energy, volume, and density. Scalar quantities can be combined using ordinary arithmetic operations, addition, subtraction, multiplication, and division. Vector quantities. Vector quantities are physical quantities that have both magnitude and direction. They require a specific coordinate system to be defined, as their direction is relative to a chosen reference frame. Vector quantities are represented by arrows or bold letters, and the length of the arrow indicates the magnitude, while the direction of the arrow represents the direction. Examples of vector quantities include displacement, velocity, acceleration, force, momentum, and electric or magnetic fields. Vector quantities are combined using vector algebra, which includes addition, subtraction, scalar multiplication, and dot and cross products. To differentiate scalar and vector quantities, consider the following examples. Distance, scalar: if you walk 10 meters forward and then 5 meters backward, your total distance covered is the sum of the magnitudes, which is 15 meters. Distance is a scalar quantity because it only involves magnitude and does not depend on direction. Displacement, vector displacement, on the other hand, is a vector quantity that considers both magnitude and direction. If you walk 10 meters forward and then 5 meters backward, your displacement is the difference in position between your initial and final points, which is 5 meters backward. In summary, scalar quantities have magnitude only and can be described by a single numerical value, while vector quantities have both magnitude and direction and require a specific coordinate system for their representation. Scalar quantities use ordinary arithmetic, while vector quantities use vector algebra for their mathematical manipulation.